Okay, looks like we're going live. Let's sign that real quick. Okay, we got the chat window. We'll say hello world. Start off with. Okay. Everything looks like it's set up properly. Looks like we got sound going, pictures going. Okay, so we'll let that complete. So today we are going to work on the HLS mirror filter and the HLS kernel filter, depending on how it's going. I've already kind of started the mirror filter, so we hopefully can get that going quickly and test it out with this new bitstream. And maybe while this is running, we could start working on the our kernel, custom kernel filter. Okay, so let's head back to where were we going to do this? Okay, so let's walk through the mirror filter real quick. Okay. That seems good. So the mirror filter, how is this different? First off, we need our own mod function because C++ ampersand sign. Let's see, CPP operators, right? What operator do we need to? We want to. Not those. Where? Right here. Why are you calling that one? Mod. So it acts differently in C++, I think. The modulo. Mod. How is this different? Okay, right here. So there's something different about it. Something happened to the modulo in HLS that I made my own mod function. I don't remember why. Looks like there's some bounding thing. It's less than 0. It looks like it gives you a negative value. So CPP modulo negative right here. Okay. I'll need to figure that out. Okay, so whatever. So before I get too distracted, yeah, so we create our own modulo function because there's some issue with bounding. But so we have our input stream or output stream, and in this situation we need to create buffers. And because the camera is using a bare 2x2 color array in this situation, oops, sorry, we're gonna have 2 line buffers for the green red rows and 2 line buffers for the blue green rows, and add this interdependency, or turn the interdependency to false so we can properly pipeline it. We bring in the pixel data, and we have the starter frame information, the end of line information, and then when the data is valid, we're going to operate on it. So first we're going to do this modulo function because I think that was the issue before when previously using this design. But when enable mirror is false, we're going to just take the pixels and output them. When it's true, we are going to take the value from this array of max width divided by 4 minus 1 minus x column. So we're going to flip it, so we're going to start from the other end. And then put that into the output value. And we're going to switch out the pixels, so the pixels line up. And then we're going to save the current pixel into the array. And so this is a 0. If we go to the 2, this is where we're going to flip it. And now this is going to be GR1, and this is going to be GR0. And that makes sense. So that's just kind of the simple mirror. And then we're going to save the output in the correct order and write it. Synthesis, it takes 3 cycles to operate this, but it's fully pipelined. So we have an initiation interval of 1. We have the 16 BRAMs for the 4 line buffers and the flip-flops and this. And I was having issues, so I pulled up the scheduler so we could walk through it. Okay, you asked why I'm using Pink OS. For this project, I'm not using the Pink OS, but I like the Pink OS. It's very nice. Pink OS is easy to develop. Pink OS allows for rapid prototyping. That's probably where I would sit that at. How delayed is the video for that? Okay. So let's walk through this while let's check. This one's in place design, so let's check why this is running. We can walk through this. So we have the data. So this is our input data, right? So it's being cascaded to the pixel data right here. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Okay, so pixel data is going to these arrays as well. Into those arrays. And this is the read action of that being transferred to this prepixel, which is then transported to this output pixel. Oh no. These output pixels, which are transported to another phase of the output right here, which is transported to that output mux, which is then transported to the result. And the result can either use the operated values, or you guys are probably not seeing this very well, or it can use the input values up here. Oh no, these are the input values for the last ones. Okay, so I mean, it looks like it's running properly. We'll see in a few minutes if we get it working. That's because I have this set to 0. Okay, so it works. But yeah, we're gonna turn it off for now. And that will finish soon. I guess I don't really want to start the next one until we figure this one out completely. These swigglies are really fun to look at. Oh, we can zoom in and look at this. Perfect, perfect. Let's zoom in. Right there. Trying to follow these things. Ah, there we go. So data goes to pixel, which goes to a bunch of these things. But this one right here is part of the output vector, then sent to this output vector, which is then sent to that value. But this one is fed in by these things, which have multiple locations, right? This based upon enable mirror read right there. And on this prepixel, which is coming from the address here. Where's the address? Where's X row? X row. X row is static, right? Yeah. X row plus equals 1. Feel like that should be working. We haven't really tested it. Guess we can go and try to debug that in hardware. Yeah, we'll have to figure that out. Routing's done. That's good. How'd routing go? Pretty quickly. So we should have a bit file soon that we can test. And hopefully it works that we can just move on to doing the kernel. And this one should be fairly straightforward. We're using a very similar format to what's happening here. This is operating on a 3x3 window, so we're just going to do it by 6. And then just have multiple line buffers. And it should be pretty easy to get going. Ugh. Come on, Vivado. Need you to run slightly faster. Or how the negative worked. Good question. Okay. Hopefully this doesn't take too long. It's a relatively small bit stream. What else could be the issue? Otherwise we're gonna have to go debug this, and this is gonna turn into a debug stream rather than an HLS video stream. We'll have to figure it out. Okay, so that finished. How easy? Let's see. Vitus HLS mark debug. Guess we're just gonna have to hunt for it in the HDL. Okay, while you're finishing, let us go look at the HDL, right? How many GRGRs are there? Would it be work.grgr? P0. Let's see where this appears and how frequent it appears. So we have these different maps. I guess we could look at these values and just snoop the addresses. I mean, that's probably what we're gonna have to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 16, right? PPG. Grr. Yeah, we'll have to pick a few pixels and just see what happens. Okay, we can do that. That's not too hard. Okay, yeah, you're not doing anything. Remind me later. Let's program this. Hopefully, yeah, program it with that one. Okay, programmed it over JTAG, continuous. Okay, this is the normal mode. So let us go into here. Why is this black? Ugh, why is it black? So something about the pixel data. Not happy. So okay, let's go and do some debugging. What do you mean? Didn't we build this? I don't know why you're unhappy. IP status. Okay. So yeah, let's just open up. We're gonna run synthesis. Rerun synthesis, I guess. And we're gonna track down where this bug could possibly be. So, let's just probably just grab the address, read and write address of these guys. Yeah, we're gonna want to grab the read write address. What's the input? The D0 and Q1. And then grab the output E0. Yeah, it says it's just straight up Q1 right there. So yeah, let's just follow E0 on the GUR, yeah. Where's that being assigned? Oh, we want to wrap search. That's the mux. Oh, outstream T data. Yeah, so we would just grab that outstream. Okay, so let's grab the addresses of the 0, 1 and go in there. So let's why is synthesis always out of date? Okay, I don't know. Close you. Closing bitstream. Close the hardware manager. Why are you out of date? Is there an IP that's out of date? On design runs. Why do you think you're out of date? Reset run. We'll reset you. And then we'll run. Run synthesis. Why? I don't know why you're not working. It's kind of annoying. We should also grab the input data, right? We want to grab the input pixel, see if it's being processed on correctly. So, like, yeah, this is seeing us just fine. But do this. What's happening? What is happening? Data temp. It's overriding temp. That's fine. Um. So 3 pixel. Yeah, I mean, it looks like it's working in the system. The only thing I can think of is that this X column is not incrementing properly. So we're going to have to follow the address line and see if the address lines are interleaving across these data. Otherwise, they don't work. So how much? We'll need 500 for a row. Then we're going to need it's going to be 2,000 for thing. And that means we're probably going to need 1,000. One for good measure. Okay, that should work. Open synthesized design. Okay, you're happy now. I don't know what was going on before. Okay, guys, let's show you how to do some fun debugging. Debugging. Okay. Oh no. We'll see. Well, maybe we'll do a software. I have to do a lot of data for software. Oh well, I guess we have the time then. Okay, let's get this netlist going. Where was this located? This is gonna be located image if right. And the camera phi. Oh, right here, HLS. We go in here, we have the mirror frame. This instance here, we have these ones. So, we want this guy right here. We want to generating a schematic off of it. I guess I double clicked it too much. Okay. So we go right. That's address, but not the cell. Okay. So we're gonna mark this as debug. We're going to mark D as debug. We have kind of curious what it looks like on the inside. What is actually being saved? So D is definitely the output. That's definitely the input. This is the normal pixel. These are the muxes. So can I mark that as debug? Mark debug. So we're gonna mark that one debug. We're going to mark that has to be the data in. We got that debugged. Okay. Okay. So we debug that one. We debug what's being stored. Mark debug. I know. Yeah, mark the whole thing debug. So those are two addresses. I'm just surprised about. Oh, this must be the DB out of the other one, right? Okay, yeah. So okay. So yeah, this is just going to the other value. So we're gonna mark debug that, mark debug that, mark debug, mark debug. So we got the addresses in and out, the data going in and out of those ones, and we think we got the mux output of 1. Okay, so next thing is to get the actual output. Okay, and what we want to do is we want to take data here. This doesn't take too long. We could just get all 40 bits. Wouldn't be a big deal. Seems to be a bigger schematic. We'll give it, what, like, I don't know, 4 or 5 minutes. What are we gonna do? Ah, looks like it generated. Nope. guess I could hunt down the itself. I'll give it 2 more minutes. See if it jumps up with anything. Otherwise, we'll just grab the output and we'll do 10. Okay, cool. Okay, working there. So we want the data. Where is the data? Here is the data. Follow that to here. We have a register slice. We have the data here, split up into the different portions. Pixel 3. Pixel 2. Pixel 1. Pixel 0. Let's mark debug that. And that's just a slice. Okay, so let's go set up debug then, okay? These are all off the pixel clock. Yes, yes, yes. Yes. Okay, yeah, let's do that. We're gonna want that value. Save it, and then we'll generate the bitstream. This may take quite a bit longer. While this is happening, we'll try to, I guess, debug it in software with incrementing values. Okay, so what can we do in our test bench? First off, we'll need to update our okay, and it saved it. Now we're gonna hit Control S, so save it to the constraints. Synthesis will likely synthesis won't reset. But if we go to our constraints now, right, we go to our wonderful constraint file, we'll have a beautiful thing at the end where it has all the probes defined. Okay, so let's generate a bitstream. And while the bitstream's generating, let's see if we can test this via software. See if we have a software glitch. Okay, so we have a mirror. .h. Inputs our stream. We're gonna have to do this ourselves. Temp.data. Temp is the input stream. And so we're gonna want out for our what did we define as both AR003 streams in and out, and we're gonna want a AP. What's this? It's gonna be, and we'll guess we'll do the frame as well. What's this? It's gonna be frame count. That one we don't really care about. Enable mirror. So, and this is gonna be mirror frame. We're gonna do in, out, able mirror, and frame count. And this is going to be do 10,000. Oh, we gotta do it embedded. So we're gonna do what? 16 rows here. We're gonna need to do and we're gonna do a J, and J is going to be 2304 divided by 4. Okay, we need to do starter frame here, starter frame. And what's the other thing we're measuring? We're measuring end of line. So we're gonna need a end of line here function call. What ins.data.pixel .p0? Is that how we're gonna do this? User key 40. Oh, we haven't specified it. We need to autocast it. So we're gonna steal this right here. Pixel, input pixel. So we have input pixel. Pixels. What? Oh, in data. How are we doing here? Op design. Okay. We're gonna do out data. Output pixels. P0. Input output. And we're gonna need a type is it gonna need a user. So it's user underscore T, I think. Right, so user underscore T, user. Right. In the starter frame, user.sof is going to be high. And then we're going to operate on this. And turn this off. Inside here, we're going to turn on. Oh, we've got to save it to it. Is this the problem? We're doing temp.data. That's probably why it's failing, and this is just. I don't know what it would be doing in that situation. Okay, so we clearly found an error already where this was data. We want user. But yeah, let's go ahead and save that for now. and recompile. Yeah, that was confusing me. Probably have to turn this mark debug off. Cancel. Yeah, we're just gonna reset the whole run. Don't worry about it, man. And we're going to take all of these beautiful things with mark debug and comment it out. Save that. Close design. Oh, okay. Waiting on that button click. Can't zoom in much better. Let us try zooming in further. That's not what I wanted. That's there. Okay, now that looks better. Okay, so this is good. Let's go ahead and get this extracted, and then we can play around with trying to get the everyone to be able to see a little bit better. I'm sorry, Vivado tools make it really hard to get it to look better. But we'll play around and see what we can do. So the issue, if we zoom back, this temp data was being read into these user and strobe, which would cause issues. And I guess the right value? That must have been causing issues in my other stuff too. Okay. But yeah. So it looks like we finished. This was done at 10:13, so we're gonna delete this guy, extract here. Okay. We're gonna open a block diagram, refresh IP catalog, update the status. So refresh. We're gonna skip and hit generate bitstream. Okay, we're gonna skip this, and it should default it. So when I generate bitstream, it will do it as one of the runs. Hopefully. And hopefully we get the mirror filter to work, and then we can work on the kernel filter next time. Which shouldn't be too much work after we debugged all these fun little issues about working with HLS. Once you get the framework for HLS going good, it's powerful. It's really powerful. The issue is just getting a template that fits your data pattern. But once you have a template that fits your data pattern, it's really easy to throw things on there. Maybe we'll add the ASCII thing later. Okay, so it's completing that run right now. Yeah, that would be causing the issue. But what was it doing? Was it just basing it on data? That is so weird. How would the line valid? I guess in line valid, when there was active data, that pixel was just high. How did it work in the first place, guys? I don't understand. Whatever pixel line valid was must have been just high the entire time, and it just defaulted to sending the pixels. It just doesn't make sense to me. Like, how does it do that? Okay, but yeah, so we have the data and we're putting it into the pixels, and we have the user data and we're putting it into the user. That's the important part. Window. Okay, let's see preferences so we can get this general appearance. Colors and fonts. Size. Appearance. Light, dark. Come on. Editor. I don't think there's a good way to do it there. Editors. Maybe we just use a different text. That's a good question. And it would be an appearance. Yeah, I don't really see a good way to do that. Okay. We're good. I'll have to see where is the mirror filter. In here, mirror frame. Maybe I should have incremented the version. I mean, we can go and track the. Let's go track the VHDL for this. Okay, right? So in this implementation, if we go here, right, we want to see in-stream user. Where is this guy going? Find. It's being registered in. Being used in a lot of different locations, which I think is definitely better than it was previously. Let's see. Okay. User. That's it being written back. That's good. Okay. Let's see. If we bring in, what's this going to? This is going to trunk. No, it's going to break line. It's stopping there. Interesting. Where's temp going? Break line. Is it actually being used anywhere? This user data. Maybe that's not the user data I'm looking for. Definitely the user data. What's this? Funkin, Viro. So we need to figure out what BRLN is. So BRLN. So now let's call it here BR_LN. BR. Okay. So we have the user data. Find. Let's make sure let's go into the VHDL here. Data in, data out. Okay, data out. So that's not what we want. Data in, assigned to that one, is not being where is it being used here? It's being used for more stuff in this one. So we'll have to assume there's 2 down to 2. What is 2 down to 2? What's in the third spot? 2 down to 2 is going to be end of line. So this is end of line. And that's used in that condition. Okay, it's used in a lot of places. Okay, so that looks promising. Where are we going here? We're in op design, post place. Let's go back to this. Whole word. Let's do whole word. Okay, so that's fine. This right here, that's the top bit. The top bit, and this is what? Line valid. So this bit right here is now our line valid bit, which is going to be here. Okay, so it looks like it's properly processing those. Oh, okay, we're in route design. I guess we'll just relax as this finishes up. Hopefully this is an interesting way to debug your HLS. It's interesting that the data here, this is the data flow. Let's see if we can look at the This is schedule data flow viewer, function call graph. What's this function? Let me click. Open. I guess we just go schedule viewer, focus, filter node. So this is, we want this the p results. That's the data valid right there. Right there, data valid. Go to source. Yeah, if line valid. Can we see like the other conditions on it? But okay, the results and user. And I get user pointer. Okay. So routing, or is that? Ah. Okay, so it looks like it already finished the routing. So we should be get the bit file soon, and then we can try it. We can try it again. We need to make sure the camera is off for that portion. And if the mirror works, we should have success to be able to go try the HLS kernel. And then we'll be able to try Xilinx's OpenCV stuff soon. Debugging these things. So fun. I should have turned the code view on. This makes it a lot easier. I need to figure out a way to have everyone view this so they can see better. But let's see. Writing the different pixels and reading the different pixels. These are writing. Yeah, these are the writing. I don't really have a location for that one, do we? Just muxing everything together. Oh, so that's the end of it. The line 58. So, okay, that's interesting. That's some terminology. So, conditional line 58 is when it starts. Conditional line 58 is when it ends. So, up here, when we have these guys, I guess they just have those. Yeah, interesting. Okay, what we got here? Okay, let's get this going. Find me later. Okay. Let's see if we can get the mirror to work in real time. Please. Okay, works. The moment of truth. We got another problem. Okay. Guess I'm gonna have to debug this tomorrow to figure out what the data issue is. Let's just make sure that we're running the correct version of the mirror in this situation, right? We got the up-to-date one. It looks good. Okay, yeah, that looks good, right? Look at it. We are got all the values. And we're just gonna have to hunt down how the data is being turned out. Guess we could try that with the test bench. Okay, so I guess next time we're gonna have to learn how to debug HLS. We need to use the software debug and then do the co-hardware simulation, and then we'll do it. Then we'll do real debug on the FPGA. No, you're not working. I don't know. Okay, does it return to normal if we write a 0 to it? Okay. Must be some issue with how these guys are being written. Okay, cool. So that's gonna be it for today. So next time we're gonna debug this. So I guess next session we'll call it HLS debug, and see how we debug something that's not operating correctly. I think you should try to get data from IP and try an application for easy debugging. Yeah. So I'm going to try the process of how we're supposed to debug this, right? So how we supposed to do the order of operation of debug is first we're going to do a mirror test bench to make sure the data is correct. Then we're going to run a C RTL co-simulation to make sure our hardware implementation matches our software operation. That's step 2. And then step 3 is where we're actually going to put debug probes into the HLS design. So we're going to have a 3-step HLS debug and see what errors we can find in our software implementation here. Because maybe the data, maybe we're writing the data incorrectly, or how the pixel T is operating, or maybe we're reading it wrong, or the X column is not operating correctly. That shouldn't really matter. Maybe X column isn't incrementing. Yeah, so we're gonna have to see how that works. So okay, join us. Let's see. So tomorrow we're gonna be looking at the precursor, first look probably. So let's say Saturday morning. I'll do a Saturday morning debug session for this because I need to get this out of the way. So it's planned for Saturday morning. Okay. Good night.